This is Rosen, Discrete Mathematics and its Applications, Section 2.4 on Sequences and Summations. Here we discuss the definition and some concepts in recurrence relations and how they relate to sequences. All right, so a recurrence relation is an equation that expresses a term of the sequence, or the nth term of the sequence, as a function of previous terms in the sequence. Okay, and then we'll start with usually an initial condition or maybe two, depending on the recurrence relation, and then every uh, term after that refers to prior terms uh, in order for them to be created or for them to be defined. Now, if we have a recurrence relation and if we find a sequence that matches it, it's called a solution of the recurrence relation. So we can use a recurrence relation to build a solution, or we can test whether a sequence is a solution to the recurrence relation. And then if we have initial conditions, those are needed because if the first term in the sequence can't reference prior terms in order to get its value, so it must be declared as an initial condition. Okay, so here's first example. My recurrence relation is the nth term is equal to the n minus first term plus 3, and I limit it to the range for n is a non-negative integer. And that I can't use my recurrence relation for the first term, a0, so I have to declare it to be 2. And that is my initial condition. So I have my initial condition and my recurrence relation. I want to know what are the first, well, the a sub 1, a sub 2, and a sub 3. Sometimes you'll hear me say first, second, and third when there's actually also a 0th term, which is the case here. All right, so let's calculate these. All right, so we know a0 is 2. We know that a1 is a0 plus 3, so 2 plus 3 is 5. a2 will be a1, which is 5 plus 3, is 8. And a3 will be a2 plus 3, which will be 11. So my sequence goes 2, 5, 8, 11, and so forth.